Welcome to this video, which is going to be about electricity. Electricity is a type of energy that we learn about in science. And today I'm going to show you how to put together a simple circuit, okay? So I have a few materials here and I'm going to go through them. I have a battery and a battery holder, and I'm going to show you how to put that together. I have a couple of wires and I expose the ends of them pretty easily so that the metal is exposed, and I'll explain why that's important. I have a light bulb, which the goal is to turn this on with our circuit, and I have the light bulb holder and our switch, which will turn the light bulb on and off. So today I'm going to show you how to put together a circuit using these materials. This is a simple circuit. First thing we're going to do is we're going to put together the circuit, and then the second thing we're going to do is we're going to test out some materials to see if we can make a closed circuit with other materials, and I'll explain. So first you take your light bulb, okay, and we're going to screw it in. And of course I probably grab one that doesn't, okay, works. I always tell my students, righty-tighty, lefty-loosey, okay, so you want to tighten it in, it's in, all right? Next thing you're going to do is you're going to take your wire, one of them, and you're going to press down on this material and you're going to tuck it in like that. So now that way I can kind of hold it and it's locked in. All right. Before we go on, let's put our battery in the battery holder. It's important to note that on every battery and battery holder you have a positive end and a negative end. Okay. So here's our positive end, and you want to match it up to your battery holder. So here on the spring side, which I want to put in first, I can see a little negative symbol. So I'm going to put the negative symbol in first, which is right here. I'm going to push down on the spring and I'm going to pop it in like that. Okay, now my battery is set in. Next thing, we're going to attach the one end of the wire to the one end of the battery. And it's a very similar piece. You press down and you push it through so it gets locked in, okay? Now right now you might be wondering, why isn't the light bulb going on? It's attached. It's attached to our power source, the battery. Well, this is what we would call an open circuit. Right now we need a closed circuit. So I have to connect a wire from not only the light bulb to the battery, but from the other end of the battery to the other side of the light bulb, which is what I'm going to do now. So if we attach it and the battery is working, you will see what happens. I'm going to attach this one end. All right, our circuit is still open, as you can see, and I'm just about to close it. And we'll see what happens. Ta-da! Oops, hold on. There we go. All right, and now we have a closed circuit. You notice before I even put it in, it was lighting up, and that is because this piece is a conductor of electricity. A conductor allows electricity to flow through it easily, okay? So again, where you're probably wondering, where is the power coming from? This is our power source in this case, okay? The battery is a power source. It shoots out electrons and it goes through the wires that are a conductor of electricity, lights up the bulb, and it keeps going around and around until I open the circuit and electricity cannot be flown through easily. On the next part of our video, I'm going to show you how we can replace the wires with something different, okay, to see if other materials are conductors of electricity. Let me explain with an example. For example, let's just say I take this plastic straw, and I'm wondering, can I connect and see if electricity can go through? I'm going to test it out. So I'm going to hold on one end of the straw at this one end of the wire, and I'm going to connect it to the other end where the light bulb is. And nope, unfortunately a straw is not a conductor of electricity. We call a straw an insulator because it does not allow electricity to flow through it. And this particular straw is made of plastic, so we know plastic must be an insulator. Let's put that to the side. Let's take a penny. All right, so I'm going to take my penny. It has to be touching the wire, okay, of one end, and then you want to attach the other side of the penny to the metal part of the switch. Let's see what happens. And you look at that. So what does that tell you? It tells you that a penny is a conductor of electricity, okay? The electricity is able to run through the penny after it gets to the wire. And again, the wire's not touching this metal part, the penny is. Pretty neat. We're going to test out 2 more items. This one is a piece of aluminum foil. And just to show you guys, I can even remove this wire completely. Let's see what happens if I do that. I'm going to touch one end of the aluminum to this end of the battery, and then the other end to this part of the light bulb. You can probably make your prediction now on what you think is going to happen. Will it light up? If it lights up, it is a conductor. If it doesn't, it's an insulator. Look at that. Sorry, my hand is blocking it. It is a conductor of electricity. Pretty neat, huh? And the last one, let's take this paper clip, which actually, no, let's take this paper clip. We have 2 different paper clips here. One of them looks like it's made up of some sort of metal material, and one of them looks like it has some sort of plastic on it, some sort of coating. I wonder if they'll work. One maybe will, one maybe won't. Let's try the blue one. Not a conductor of electricity. But this one seems to be made up of different material. So let's try this. Conductor of electricity. I hope you learned a lot watching this, and yeah, have a great day.